All right, this is your recording for activity 17 and 18 review. So the first several problems on page 275 and 276, really numbers 3 through 6 were all just a review of factoring. So I can't go through all of them. I'm just going to pick a couple. Please remember that you should be going through that factoring checklist every single time. So first we look for and take out GCFs. Then we look for special products, which could include difference of squares, PST, so difference of squares, PSTs, and sum or difference of cubes. Then next, after that, we look for chart factoring. And then our last choice would be factoring by grouping. That only works if you have 4 terms. So please go through this for all of the problems. Again, I'm just going to try to pick a few of each type, but it's not going to be all inclusive. So first one I'm going to look at is to look at 4A. So 4A's original problem, I had 8x cubed minus 64x squared plus x minus 8. So first I look for a GCF. I do not see one because this term is not divisible by 8 and this one is not divisible by x. So no GCF. I know it's not a special product because it has 4 terms. That also tells me it's not chart factoring. Remember that chart factoring is only for trinomials. This is for 4 terms. Difference of squares are only for binomials. PSTs are trinomials. And sum and difference of cubes are also binomials. So that helps us, again, very quickly say, oh, this is factoring by grouping. So group the first 2, group the second 2. GCF of the first group is 8x squared, which leaves me with x minus 8. The second group doesn't have a GCF. So remember, when there is no GCF with factoring by grouping, we write a 1 because you have to write something. And then x minus 8. Remember that these parentheses have to match because in the next step I take the parenthesis that they shared, which is x minus 8, and then I take the GCFs and make a second parenthesis with it, 8x squared plus 1. So next thing I would do is check to see if it factors further. I know that this first one doesn't because it's linear. The second one, 8x squared plus 1, it's a binomial, so I'd be looking, could it be a difference of squares or a sum or difference of cubes? Well, I know it can't be a difference of squares because this is a plus sign. Sum of cubes, 8 has a perfect cube root, so that's good. 1 has a perfect cube root. However, x squared does not. If this were an x cubed, we could go further, but in this case it is just x squared, so there's nothing else I can do with that. So that was my final answer. Remember, the order of the parentheses is not important. Next one I want to look at is 6b. So we've got 81x to the 4th minus 625. So, as always, first thing I do is look for a GCF. In this case, there isn't one, so then I go to special products. First, I look for difference of squares. So I ask myself, does this have a perfect square root? Yes, that'd be 9x squared. And then I ask myself, does 625 also have a perfect square root? The answer is yes, it's 25. It is a minus between it, so that makes it a difference of squares. So it fits the mold. Difference of squares, remember we factor into 2 binomials, one with a plus, one with a minus, and all we do is put the square root of the front in the fronts, so 9x squared, and then the square root of the back in the backs. So I factored my difference of squares. Now I need to look to see if these factor any further. So first one, These are also perfect squares, but there's no such thing as a sum of squares. And these do not have perfect cube roots, so it can't be a sum of cubes. So this one's good how it is. This one, however, I have perfect squares again with a minus sign. So this one factors further. So I'm going to bring down the first one just as it was. And then I need to factor this into its own difference of squares. So binomial times a binomial, one with a plus, one with a minus. Square root of the front is 3x, so those go in the front. Square root of the back is 5, so those go in the back. Now I check again. I know that this doesn't factor further. And now these are both linear, so that's as far as I can go. All right. Next one that I want to look at is 6c. This will be the last plain old factoring one that we look at. So 6c, I've got x to the fourth plus 17x squared plus 60. So I look for a GCF. There isn't one because 17 is prime. Then I look for special products. It's a trinomial, so that could only be a PST, which I know quickly it's not that because 60 doesn't have a perfect square root. So next I look for chart factoring. I look to see if this is the easy type or the harder type. This is going to be the easy type because my leading coefficient is a 1, nothing in front of this x to the fourth. So I make my chart. I'm looking for what multiplies to 60 and adds to 17. So again, you don't always have to get it right on the first try, so you might try several different factors until you find the right one. So let's say you said, okay, well 20 and 3 multiply, but those add to 23, so that doesn't work. So that's too big, so try going smaller than that. So you might say, okay, 60 is also 15 times 4. Well, 15 times 4 is 60, but plus 4 is 19, so still I need to go a little smaller. 60 is not divisible by 13, 14. It is divisible by 12. It's 12 times 5. 12 plus 5 is 17. So yay, there are my winning numbers. Because the leading coefficient was 1, that means this is the easy type of chart factoring where my winning numbers go in the back. So plus 12 plus 5. In the front goes the square root of this first term, which is x squared. Remember that it should always match the variable of the middle term. If I FOILed that back out to check, I would get 12x squared plus 5x squared, so that does give me 17x squared. So then I look to see if either of them can factor further. Neither of them have GCFs. As far as special products go, they're binomials with a plus sign. So the only thing I could look at would be a sum of cubes, but these are squareds, not cubes. So that means these do not factor further, so that is my final answer. Okay, next one I want to look at are in number 8, where it asks you to find the zeros algebraically. So we're going to look at 8b. Pick a different color here. So 8b, my original function is g of x equals 3x cubed minus 3. So algebraically, what I'm going to be doing is setting it equal to 0 because we find the zeros by putting in 0 for our y value and solving. So I put 0 in here, and now I'm going to solve for x. So it's cubic, so it should be factorable. So I look at it. First I look for GCF, which there is one. So I take out my 3, my GCF, which leaves me with x cubed minus 1. Next, I look at my parenthesis to see if it factors further. It's a binomial, so that means I'd be looking at either difference of squares or difference of cubes. Since this is a 3, that means we're looking, this is a difference of cubes because 1 is also a perfect cube. So I keep my 3 out in front, and I'm going to factor this guy further. Remember that sum and difference of cubes factor into a binomial times a trinomial. So then I use my SOAP acronym for filling in my signs. So same sign as the original, which is a minus. Then opposite sign as the original. And then always positive for the last one. Now I take the cube roots. Cube root of x cubed is x. Cube root of 1 is 1. To get the trinomial, I look at the binomial. To get the front, I square this front. So that's x squared. Middle, I multiply. So 1 times x is x. And to get the back, I square the back. 1 squared is 1. Remember that we said that these trinomials that come from a sum or difference of cubes will never factor further. So you don't need to look at it. It's not going to. This doesn't factor further because it's linear. So that means I should be ready to solve for x. I can use my zero product property, which tells me to set each of the factors equal to 0. The 3 isn't a factor because it doesn't have a variable. So just these two. So I do x minus 1 equals 0. And x squared plus x plus 1 equals 0. So this one is very easy to solve for x. I just add the 1. I get x equals 1. This one, however, I already know that it's not factorable. So that means that this is a quadratic that I'm going to have to solve either by completing the square or using the quadratic formula. In this case, I would use the quadratic formula because although a is 1, b is not even, which means if you complete the square, you're going to have to use fractions. So I'm going to use the quadratic formula. In this case, my a, my b, and my c are all 1. So quadratic formula, the opposite of b plus or minus the square root of b squared, 1 squared is 1, minus 4 times a, which is 1, times c, which is 1, the whole thing divided by 2 times a. So now I'm going to simplify. So as I look at that, I've got negative 1 plus or minus the square root. This is 4. 1 minus 4 is negative 3. On the bottom, 2 times 1 is 2. So the only thing left to do is to simplify my radical, which the 3 doesn't simplify, but the negative means that there's an I. So this is negative 1 plus or minus I radical 3 over 2. So these are the zeros that I listed on your answer sheet. X equals 1 and x equals negative 1 plus or minus I radical 3 over 2. So remember that we should always check when we get done to make sure the number of zeros matches the degree. The degree was 3, 1 0, the plus is the second 0, and the minus is the third. So I have them all, and those are my answers. All right, next ones are when they give you the degree and some zeros and ask you to write out the function. So I'm going to look at 12c for this one because it's harder than 12a. It tells you that n is equal to 3 and then tells you that x equals negative 2 and x equals 1 plus 2i are zeros. So the very important thing here is that we need to remember that imaginary or complex roots always come in pairs. So even though they didn't list it, if x equals 1 plus 2i is a 0, that means x equals 1 minus 2i is also a 0, which makes sense because if n equals 3, I should have 3 factors listed. So this is all of them. So now I'm ready to start my working backward process. I need to get my x alone. So over here, I get x alone by adding 2 to both sides. So that gives me x plus 2 equals 0. Over here, I would subtract the 1 and subtract the 2i. So that gives me x minus 1 minus 2i equals 0. And over here, I would subtract the 1 but add the 2i. So that gives me x minus 1 plus 2i equals 0. Now, once you've got the factors written out, then we write them as a product. So we write x plus 2 times x minus 1 minus 2i times x minus 1, Oops. And of course I can't use an eraser on here. Let's see if I can write with white. Maybe that'll help. Just as good as erasing. There we go. Okay, so x minus 1 plus 2i equals 0. And this is what I have to multiply out in order to get my function. Now, again, other thing that you have to remember is that you always want to multiply the imaginaries by each other first. Save this guy for last. Now, just like I did when we did these examples in class, you can, if you are more comfortable, take this and this and set up a box, a 3x3 box where you have 9 terms, and do it that way. I like to try to make these binomials because these match, which means we can group them and consider this that's in blue parentheses now a single term. The reason why I do that, again, I showed you this in class, but it's because now this is a sum and difference pattern. I have essentially a minus 2i times a plus 2i. And you can do that substitution if you want. So I am just going to say, well, now I've made it a binomial, which means I can FOIL it. So firsts would be x minus 1 times x minus 1, which is x minus 1 squared. Outsides are going to give me plus 2i times x minus 1, but the insides are going to give me minus 2i times x minus 1. Those are going to cancel each other out. So the only thing left are my lasts. Negative 2i times positive 2i is negative 4i squared. So this helps me because now I can square this out, which gives me x squared minus 2x plus 1. And then I know that I squared is the same thing as negative 1. So negative 4 times negative 1 is positive 4. And so I have x squared minus 2x plus 5 to now multiply by my x plus 2. Again, I prefer box multiplication when I get more than a binomial times a binomial. If you like to do the double distribution, please feel free. I'm not saying that that's wrong. I just think the box organizes it a little better, so I'm going to do it with the box. Okay, so x times x squared is x cubed. X times negative 2x is negative 2x squared. X times 5 is 5x. 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. And 2 times 5 is 10. So then I've got all of my terms in my box, and I can combine my like terms. I've got 2x squared and negative 2x squared, so those cancel each other out, so cross those out. Then I've got 5x and negative 4x, which just gives me x, and nobody else has a like term. So that means that my answer is going to be f of x equals x cubed plus x, because that's what 5x minus 4x is, and then plus my 10 from down here. And there we go. Number 13. You're just telling what the degree is. I really hope you didn't actually find the polynomial, because all it wanted on number 13 was for you to tell it the actual degree. So, for instance, on 13b, it told you you had zeros, x equals negative 2, x equals 2, x equals 0, and x equals 4 plus I. So the degree of the final polynomial, you just count up all of the zeros, including any that might not be listed. So here, again, they listed this guy, but they didn't list its complex conjugate. So you know its complex conjugate has to be there too. So 1, 2, 3, 4, 5 zeros, which means that the answer is degree 5. All right, so that is activity 17. Now let's take a look at some stuff from activity 18. The first 8 problems in activity 18, there really isn't work to show. They're multiple choice and there really isn't work. So I just want to take a look at those here real quick. So these were the questions and it gave you graphs to match. So I'm not going to do all of them. I'm just going to pick a couple of them and make sure you know why the answer was the answer. So number 1, an even function with no real roots and a positive leading coefficient. So if the function is even, that means that it needs to be symmetric about the y-axis. No real roots means no x-intercepts. Positive leading coefficient tells you what kind of end behavior you can have. So if you look, you're looking at these choices. It's not allowed to cross the x-axis, we know, because it has no real roots. So as I look, the only choice that doesn't cross the axis at all is F. And you check to make sure it meets everything else. Is it symmetric about the y-axis? Yes, it is. It says the last part was the positive leading coefficient. We know that this would have a positive leading coefficient because the end behavior there is going up on both sides. So that would happen for a positive leading coefficient if the degree were even. So that's why we chose F there. Just to look at another one, when, for instance, you look at number 5, this tells you it's a cubic with a positive constant. So the cubic, and notice the difference here, up here in 4, it was a negative cubic. So in this case, my A is listed as positive, which means I have positive odd end behavior. And this part tells me that I have a y-intercept that is positive, so plus D. So that's why when I look at number 5, I chose choice H, because this does have end behavior that matches with positive leading coefficient and odd degree, and it does have a y-intercept that is at a positive value. The reason why we know that 5 can't be, for instance, let's see if there's another one that matches. Well, there wouldn't be another one that matches at all anyway. So let's look at, when I look at 8, for instance, has a negative leading coefficient and an odd degree and a negative y-intercept. So I would look for the negative y-intercept first. A has one, but it has positive even end behavior, so that can't work. This one has a y-intercept at 0, so that doesn't work because this says negative, and you would just have nothing if it were 0. This one, again, 0 as its y-intercept, so that doesn't work. This one has a negative y-intercept, and so I look and see if it could possibly have negative odd end behavior, which it does. Left arm's up, right arm's down, which is what happens on negative odd. Also, if you look at the number of relative extrema, there are 1, 2, 3, 4, which means that this has to be degree 5 or higher. This graph would not be possible for anything less than degree 5 because remember, the number of relative extrema, the maximum number that you can have is 1 less than the degree. So degree 5, max of 4 relative extrema. Degree 3, max of 2 relative extrema. So this couldn't be degree 3 because it has too many mins and maxes. Okay, so hopefully that gives you an idea of how to pick on those ones. The next one that you needed to do was number 11. So this is one where if you were given this and it weren't already factored for you, this one would be on a calculator portion if it weren't already factored for you because of the fact that this can't be factored using our traditional methods from 17.1 because it has more than 4 terms. So when I look at number 11, we can see its original and we need to create a graph. All of the qualifications that we talked about for graphs need to be present in your answer to number 11. Now, they already did some of the work for you, so that makes it a little bit easier. When you go to create your graph, we said in our notes it has to have accurate end behavior, so that's relatively easy to come up with. Accurate end behavior in this function, it's a negative leading coefficient and an even degree, so that means I know that its end behavior, negative and even, looks like this. That means it approaches negative infinity on both sides of the graph. I have to have all of the x and y intercepts with algebraic work. Now, obviously, they've already done a lot of the algebraic work for you, so all you really need to do here is to copy the factored version. So that's negative, we've got x minus 1, x minus 5, x plus 2, and x minus 7. So negative x minus 1, x minus 5, x plus 2, x minus 7, I'm just going to double check that, minus 1, minus 5, plus 2, minus 7. So once it's already factored, then all I need to do is find the zeros. So that means that x equals 1, x equals 5, x equals negative 2, and x equals 7 are my zeros. So that means when I list my x-intercepts, I've got 1, 0, I've got 5, 0, I've got negative 2, 0, and I've got 7, 0. So I've got 4 x-intercepts that I got from that factored version. These, probably should label them x-intercepts. Then I need my y-intercept. My y-intercept I don't have to show separate work for, but I do need to look at the unfactored polynomial. So the unfactored polynomial, my constant is my y-intercept. So that's positive 70. So my y-intercept I list at 0, 70. So I'm going to go ahead and start drawing this on my graph. Now, obviously, I'm going to need a pretty big scale for the y-axis. The x-axis, it looks like I'll be okay if I stick with counting by ones. I'm actually going to make my graph down here because I'm afraid I'm going to run out of room. Okay. So when I go to draw my graph, I need accurate x-intercepts. And remember that you only have to list the scale if you're choosing something other than 1. I've already listed my x-intercepts. If you don't have them listed, then you would need to actually label them on the picture. But since I already listed them, I can just go ahead and make dots. So negative 2, positive 1, positive 5, and positive 7. Once I have those, I can also fill in my end behavior. I know that it goes down on both sides. So after this, it needs to go down, and after this, it needs to go down. So now I need points in between. One of them is going to be my y-intercept. So again, you can choose what to count by. I'm going to go ahead and count by 20s. So 20, 40, 60, 80, 100. So 0, 70 then would be right here. So this can count as the point between these zeros. So again, as long as you have a point between the zeros, if you don't get the max exactly right, that's fine. I drew it in for those of you who happened to want to pick those points. On the answer sheet, I drew it in, but you don't necessarily have to have that accurate. But you know it has to be symmetric, so if you're trying to connect and keep the sides even, you're going to get it pretty accurate. I think it's like 96, and you can see where I connected it, it's almost 100, so it looks great. Okay, so now in order to meet the requirements we talked about in the notes, I need an exact point between these two zeros and between these two zeros. So I can pick any integer between the 1 and the 5. You generally want to go in the middle, so I would probably pick 3 here for this one. So my work, you have to have work for it. You can either set up a synthetic division with the coefficients from the original, so the unfactored version, so -1, 11, -21, -59, 70. So you can either do that, or you can actually show plugging in the 3. So if you prefer, you can write out negative and then put the 3 in parentheses, 3 to the 4th plus 11 times 3 cubed minus 21 times 3 squared minus 59 times 3 plus 70. I don't care which way you do it as long as you show the work. I just prefer this because I prefer multiplying and adding to exponents because I can do it faster. So you can see just how fast I can come up with this. So I find when I plug in 3, I should get -80 because that's my remainder. So that means, again, I'm counting by 20s, 20, 40, 60, 80. So when x is 3, I've got -80 for my y coordinate. So that allows me to go ahead and make this connection here. Now I just need this one left. The only integer between is 6. So again, you can either plug it in or use synthetic division. So -1, multiply, add, multiply, add, multiply, add, multiply, and add. I've made a mistake somewhere, but I caught it myself. Yay for me. Because I know you would catch it if I didn't. Sorry, I knew this didn't come out right. Okay. So this was -5, and then this gives me a remainder of 40, which hopefully 40 is what you got when you plugged it in. So that means when x is 6, y is 40. So I can plot this point. Now that gives me my last point to connect. Again, I've got algebraic work to back up those exact points, and I've got a really pretty picture. So that's what I'm looking for on any graph that you are asked to do, except, of course, when it's not the answer but a part of your work. Okay, next one I want to look at is 14a. It gives you f of x equals -4x cubed minus 13x squared minus 6x minus 3, and asks you to list the possible rational roots. So this is your p over q thing. Remember that p, we're listing the factors of the constant. So factors of -3, which would be plus and minus 1, plus and minus 3. And then in the denominator, q are factors of the leading coefficient, so factors of 4. So plus and minus 1, plus and minus 2, plus and minus 4. And then I just need to do the ratios. Use a systematic method. I start with this, and then I use the 1 for my numerator with all of the denominators. So plus and minus 1 over 1 is just plus and minus 1. Plus and minus 1 over 2 gives me positive and negative 1/2. Plus and minus 1 over 4 gives me plus and minus 1/4. And then I move to the 3 and do the same thing. Plus and minus 3 over plus and minus 1 just gives me plus or minus 3. Then I end up with plus and minus 3 over 2 and plus and minus 3 over 4. Again, the order that you list these is not important. So if you did it in a different order, that's perfectly acceptable. 16a, remember regular algebra 2, you did not have to do this. This is just for honors. So 2x cubed plus x squared minus 5x plus 2. And you're looking for how many possible positives and negatives. So I count the sign changes for the positives. The first term is positive, so moving here is not a sign change, but this is. So one sign change, and then 2 sign changes. If there are 2 sign changes, that means that there are either 2 or 0 positive real roots. For the negative, I have to find h of negative x first. So if I plug negative x in, negative x cubed is going to give me a negative. So h of negative x, it's going to be negative 2x cubed. When I square a negative, it's still positive, so this will be positive. This will become positive, because a negative times a negative is a positive, and then of course the 2 won't change. So when I look at the negatives, I start negative. Here's a sign change. This is not 1, this is not 1. So that means there's 1 negative real root for sure. All right, number 19. Number 19 is quite time consuming, but that's why the whole beginning was quick with multiple choice and why I didn't assign you too many of these, because it gives you your p of x function and then tells you to apply the remainder theorem to all of its possible roots. It has 6 possible roots, because if we do the p over q thing, our possible roots end up being plus and minus 1, 2, and 4. So there are 6 possible roots, which means you need to do 6 synthetic divisions. There is no shortcut here, guys. Sorry. You need to do a synthetic division with each of these terms. Now, when I choose positive 1 and I do my synthetic division, 1, negative 5, 8, negative 4, and I work that out, it gets a remainder of 0, which means this is a 0. 1 is. It's an x-intercept. So you identify it. You can either say x equals 1 is a 0, or you can just list 1, 0 as your x-intercept. Either of those would be fine as to how you write it. I don't care which way. So either just say x equals 1 is a 0, or put 1 comma 0 is an x-intercept. So that's what you do when it comes out with a remainder of 0. If I try negative 1 then, I've got 1, negative 5, 8, negative 4, and I do the same thing. This time, I don't get a remainder of 0, I get a remainder of negative 18, which is why it tells you to find the zeros and points on the graph, because this work tells us that negative 1, negative 18 is on the graph. So make sure your work has 6 synthetic divisions. You have to try all of them, because even if you know it's not going to be a 0, it still is giving you a point to try. All right. Last one I'm going to do is one of the inequalities. So I'm going to do number 23. So it was x cubed minus x squared minus 36x plus 36 is less than 0. So the nice thing, and this isn't true for 24, about this one is that I've already got a 0 on the right. On 24, you have to subtract the 32 in your first step. Here I don't have to do that, so first thing I do is I substitute an equal sign in place of my inequality, because I need to factor this and find its zeros. So I have to factor by grouping. I know that because there's no GCF and there are 4 terms. So GCF of my first group is x squared, which leaves me with x minus 1. GCF of the second group is negative 36. Has to be negative because remember these guys have to match. So that gives me x squared minus 36 times x minus 1. This guy is a difference of squares, so x plus 6 times x minus 6, and then bring down my x minus 1. So this is the final factored version, which tells me that I should have zeros at negative 6, positive 6, and positive 1. So when you draw your graph, and you must draw a graph, it's part of your work. These ones, you do not have to have accurate mins and maxes, because the graph isn't your answer, it's your work. So all I need 2, 3, 4, 5, 6 are labeled zeros, so -6, and then +1, 2, 3, 4, 5, 6, and then just a sketch of its shape. So if we graph this in our graphing calculator, you'll see that it looks something like this. And so now I use the graph as part of my work. I go back to my original and I see what its symbol was. This was a less than. So I put a squiggle on everything that is less than 0 on the graph. So what's in red here? And then I just write my answers. Remember that whenever it's an arrow, it's a plain old single less than or greater than. In this case, it's a less than because it's values to the left. So I say my boundary is -6, so x is less than -6. And because there's more than just this answer, there's this also. That's a loop. When you have a loop, you write a sandwich. The numbers on the ends of the sandwich should match these numbers, 1 and 6, so x is also between 1 and 6. So you would have solutions in both of those places. All right, that should cover about everything on Unit 3, Embedded Assessment 2. Remember that for the test, you should watch this video and the 14 through 16 video because the test is cumulative. So make sure you're prepared for that. Good luck.